Axes3D. Axes3D is a Seattle Central package command that creates a 3D coordinate axis and controls the display range for your graph. We will use Axes3D in this example. Create a graph of the parametric function cosine sine t squared with t between -5 and 5. So to get started, let's just first create the parametric plot of this graph. Cosine, sine, and t squared, running from -5 to 5. And when we hit Shift-Enter, we see a problem here when we just enter the parametric plot by itself. Mathematica's box displays the window, but it's not easy to read. The 0, 10, 20 is pretty good, but this part is difficult. And the automatically chosen display window is difficult to use or see. So this is where we will use Axes3D to help. Axes3D is a Seattle Central package command. So before running it, you must make sure you've activated the Seattle Central package as we've done here. We need to show axes at the same time as the parametric plot. So I'm going to type in show Axes3D. And I'll just put an input of 5 to get going to see the idea. And I put another brace to include the show. So we have show Axes3D, comma, parametric plot. Shift-Enter. And what we see is an improvement on the graph that we had. X, Y, and Z are automatically labeled, and we have a more traditional axes shown instead of the outside box that Mathematica automatically displayed. And we can see, since I did 5 as the input, X, Y, and Z all run from -5 to 5 in this graph. Now, what we also might notice in this graph is that, let's make it a little bit bigger here, is that we might want the z-axis to be a little bit bigger because I think it's going to run from 0 to 25, 5 squared in the z coordinate here. So what I'm going to do is put in a list as the input. If I put 5, 5, and 25 as my input for Axes3D, it creates an axis where X and Y are both -5 to 5, and Z is -25 to 25, which is an improvement, but perhaps we want Z not to have all this wasted space here. The way we do that with Axes3D is for any of the coordinates, we can type in a list where with 2 entries, the min and the max for the display. Shift-Enter, and we see this looks pretty good. Z runs from -5 up to 25. Another feature of Axes3D is, I'm going to just move this down to make this easier to see, is axes ticks. Axes ticks creates tick marks along the axis. The most simple way to use axes ticks is just to do axes ticks, arrow, true. We hit Shift-Enter, and we scroll down and see the default is that the axes command creates a tick mark on every integer, which is pretty good for the X and Y, But as we can see, Z, this is a little bit difficult to read. And for another example, maybe Z goes all the way to 100, and these would be unreadable. So what we're going to do is look at how to customize the Axes ticks for Axes3D. To do that, we create a set of lists. We'll have to have a list for X, Y, and Z. So what I'm going to type is -5, -3, 3, 5. And this will create tick marks at these values along the x-axis. You can type whatever you want. I'm just picking this for X and Y for simplicity and demonstration purposes. Now, for Z, I might want something different. I'm going to show that you can use the range command. And maybe what we'll do for Z is we'll start at -5, end at 25, and have a tick mark every 5 units. I end the brace for range, and that will end the Axes ticks input. We hit Shift Enter. And now we see a very nice graph. X having tick marks at -5, 3, 3, and 5, and nicely spaced tick marks for the Z coordinate here, for the Z axis.